All right, so in this video, we're just continuing our discussion with trigonometric equations. And you'll see in this example, the instructions say find all real numbers. So now we're back to radians and we're back to having k's in our final answer. But you'll also notice this one now, the angle isn't a single angle. In fact, this one is x divided by 3. So we'll have to take that into consideration as well. So other than that, all rules still apply. We'll go ahead and isolate the trig function. So sine of x over 3 is -1. This is not one where we can draw a triangle. So as I've said so often, we'll need to resort back to the unit circle. Remember, sine is the y coordinate on the unit circle. And so at this point right here, which would be 0, -1, that's where sine is -1. And so the angle that we're searching for would be 3 pi over 2. Now, it's not going to be x equals 3 pi over 2, but instead, it's actually going to be x over 3. So again, we haven't accounted for that yet. All we've done is the traditional stuff from the last few problems, but in this case, it's going to be x over 3 equals the 3 pi over 2. So x over 3 equals 3 pi over 2. And as we talked about a moment ago, we still have our 2k pi on there. So to get x all by itself, all that I'm going to need to do is multiply everything by 3. X would equal 9 pi over 2 plus 6k pi in this case. So again, really nothing different. We just have to remember that when we find our answers, we have to remember to say that it's equal to the angle that we started with in parentheses and then solve that for x to finish it up. All right, so in this problem, now we're going to look at another trigonometric equation where they specify to give answers on the interval 0 to 2 pi. So a finite number of solutions, but in radians. So in isolating the trig function, we'll go ahead and we'll move the 2 root 2 to the other side, divide by 4. So cosine of x minus pi over 2 would equal root 2 over 2, which in case you're used to seeing that as 1 over root 2, that is the same thing if you just rationalize. So let's see, cosine is positive. So cosine's positive in quadrants 1 and 4. There's 1 and there's 4. This would be a 1 and a root 2, with these being 1s and -1s respectively. Suggesting our reference angles are pi over 4 on both of those. So now I'll go ahead and mark the angles that I'm searching for here. That might be the first one, that might be the second one. And so this would suggest that x minus pi over 2 equals pi over 4. And again, notice how the x minus pi over 2, that came from this guy right here. So x minus pi over 2 equals pi over 4. I'm not putting the plus 2k pi on there because of the instructions stating they want a finite number on the interval 0 to 2 pi. And the other one then might suggest x minus pi over 2 equals 7 pi over 4. Now, we haven't solved either one of these for x like we're supposed to. So for that first one, if I move the pi over 2 to the other side, you'll actually end up with x equals 3 pi over 4, which is in the interval. Now, similarly, if I go ahead and move the pi over 2 to this side, I'm going to end up with x equals 9 pi over 4. Now, 9 pi over 4 is not in the interval that they suggested. So we have to figure out a way to rewrite that. Well, what we could have done is we could have come back to the original and said, instead of using 7 pi over 4, understanding that I'm going to need to add pi over 2 over, I could have went ahead and just said, all right, I'm going to choose x minus pi over 2 equals negative pi over 4. Again, notice that this big green angle here and this yellow angle here represent the same thing. So if I choose the negative pi over 4, now when I add the pi over 2 over, I'll actually get x equals pi over 4 for a final answer, which is within the bounds of the original problem. All right, so the next example, again, we're just now taking it up another step. One of the big things to observe in this problem, past the instructions needing us to provide all real numbers, would be the fact that we have now a double angle and a single angle included in the same equation. So fortunately for us, we have identities to help with that. So the first thing that I'm going to do is I'm actually going to take this sine 2 theta and rewrite it as 2 sine theta cosine theta, and conveniently the 1/2 and the 2 go away, and then I'm left with sine theta cosine theta, and then I'll go ahead and subtract the sine squared theta. Okay, now to go ahead and get this in a place where we can do something with it, it looks like we can factor out a sine of theta, leaving us with cosine minus sine, setting both equal to 0. We end up with this. Now, for the first one here, sine theta equals 0. This one's pretty easy. We can draw a picture if we need to. We can think about graphs if we need to. You've done this one enough to know already that when sine is 0, that means the angle has to be k pi. So we're just going to cut to the chase there. But this other one's kind of interesting. So what I'll do is I'll actually go ahead and set cosine equal to sine. Now, early in the problem, I want to point out to you guys, when you get to this step like this, it's not that you want to divide by sine, because if you divide both sides by sine, you could potentially be dividing by a 0. So instead, what we do is we move it over, we factor it out, then we set both equal to 0. In this step right here, I'm actually going to go ahead and do what I told you earlier to be wary of. I'm going to divide everything by cosine. Now, the reason why this is possible is because I know that when cosine equals sine, that's never going to be when cosine is 0. So again, when cosine equals sine, that's never going to occur when cosine is 0. So when I divide by cosine, I'm 100% certain I'm not dividing by 0. Now in doing this, you can see that over here on the right, sine over cosine would give us tangent, and then cosine over cosine would equal 1. So for us, tangent of theta equals 1. This suggests theta is going to be your pi over 4, and then plus k pi, again, because it's a tangent trig function. So you can certainly draw that one out if you need to. Tangent is positive in 1 and 3. If we mark this as a 1, a square root of 2, a -1, a -1, a square root of 2, your reference angle was pi over 4. So that's where the theta equals pi over 4 came from. And then if we add a pi to it, there's the plus k pi. Okay, so now in this example, we're going to be solving this guy on the interval 0 to 360 degrees. So answers in degrees, and there'll be a finite number of them. Now, when I look at this one, I notice I do have all single angles, which is helpful. And I also note that I have cosecants and cotangents. Cosecants and cotangents generally go well together, especially when they're squared. In fact, that's one of your Pythagorean identities. So what I'll actually start off doing in this case is squaring both sides. So on the left, when we square this, we get cosecant squared theta minus 2 root 3 cosecant theta plus 3 equals cotangent squared of theta. So now, when I go ahead and I'm just going to rearrange some things here real quick. And in doing so, I'll pull this guy over to this side. Now, cosecant squared theta minus cotangent squared theta, that should be something you recognize. Oops. Cosecant squared minus cotangent squared, that's equal to 1. So a 1 from that guy plus a 3 gives us a 4 equals 2 root 3 cosecant. So now I'll go ahead and divide both sides by 2 root 3. And you can see how cosecant of theta would now equal 2 over root 3. In other words, sine of theta equals root 3 over 2. All right, so we've taken something that started off kind of not working out well together, but by squaring both sides, we ended up with something that's pretty commonly seen. So sine is positive in quadrants 1 and 2. That'll be a square root of 3, a 2, a square root of 3, a 2, 1s and negative 1s. We're in degrees again, so being in degrees, that's going to be not pi over 3, but instead 60 degrees as our reference angles. So the two angles we would have here would be 60 degrees and then 120 degrees. So theta equals 60 degrees and 120 degrees. Now, unfortunately, that's not our final answer. If you remember back from algebra, anytime you square both sides of an equation, you always run the risk of creating extraneous solutions. So that means that we have to take both 60 and 120 and go back into the original to see if it works. And so conveniently, you already have your triangles drawn. You can take those ratios, plug them back in there to see if it checks out. And in doing so, you'll learn that 60 degrees does not work, but 120 does. So the final answer to this problem would only be 120 degrees.